Hi everyone, welcome to Knowledge Center. Today we shall take up a new question on microcontroller programming. Let's see the question now. Add two 8-bit numbers located at 9050H and 9051H and store the 16-bit result at 9052H and 9053H. So this is a program to add two 8-bit numbers, and in question they have mentioned those two 8-bit numbers are stored at 9050 and 9051. So at 9050H we have to give some input, and at 9051H give another input, and those two inputs has to be added together. And where should I store the result? It is clearly mentioned that the result has to be stored at 9052H and 9053H. So before understanding the way of writing a program, let's understand the logic here. See, they have mentioned it very clearly. We are adding two 8-bit numbers and the result may be 16-bit. That is why store the 16-bit result. That is the point mentioned here. Store the 16-bit result at these two locations. We used two locations to store the 16-bit because at one location I can only store 8-bit. As we all know, microcontroller is an 8-bit processor. It is going to just store 8-bit data in it. So we need, if we are getting 16-bit data, we need two 8-bit registers. So I used 9052 and 9053, two 8-bit registers. Combinedly we can store 16-bit register. Let me explain with an example. Say at 9050, I'll take one data like this. Say 8 and A. This is the one data. At 9051, let me take one more data, that is C and 2, and add these two. Generally you should take up some hexa numbers because this is an hexadecimal concept. So let's take hexadecimal numbers. You can take simple numbers also, but when you take the larger number, then you will get actual concept. You will understand the actual concept. Say, let me tell you how to add this. 8A plus C2. A plus 2. After A in hexa what do you get? B and C. So after A if we add 2, we get B, C. So C will be the answer. And 8 plus C. So after C you add 8. So after C what do you get? D, E, F. And after F you get 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Right. So you are going to get 1, 4. That will be the answer here. So we got some result like this. This is not 8-bit result. Say this is not 8-bit result because we got 1, 4, C. Here C means we need 4-bit to represent this, 4-bit for this, 4-bit this for this. And remaining here we don't have anything, so let me write it as 0. Okay. So this can be splitted as into two 8-bit data. 4C is one 8-bit data and this is the another 8-bit data. Okay. We can say this is the lower byte and this is the higher byte. Now according to our microcontroller, if you get result like 14C, you can't store 14C in one location. You can just store one 8-bit, that is 4C, for this location, and this 01 has to be stored here. This is the logic. Okay. So let me take the same example here. 9050, let me give input as 8A, and at 9051 I will give input as C2. You should take an X data view. In external memory you should give this data, right, once after writing a program. So after doing this, when we add it, you get result as 14C. So 4C will be stored in 52, and then 1, that is a carry. Generally how we got this 1? Because of carry. This is a carry, right? So that if you have a carry, you should put that carry here. If you don't get this carry, it will be 0. So you put 0 here. So that is a condition you need to check. Okay. So now let's see how to achieve this. How to take these two numbers and add it using a microcontroller 8051. All programs has to be started with the ORG. So let me start with that. ORG 000H. This is the starting address of a program. Now what you need to do? I should give the data. Where should I give data? I should give data at 9050. So first let me assign this to a DPTR. And one thing you need to highlight here. This is a 16-bit address. And 16-bit address can be fetched through DPTR only. And we have only one DPTR. So I can assign 9050 for one DPTR. Next you should get 9051. For that I don't have another DPTR. So what I do, I will increment that and I will take 9051. So I can only assign one 16-bit address to DPTR. So first I will take this address. So to do that, we can write an instruction called move DPTR hash 9050H. So once you write like this, 9050H, that address will be assigned to DPTR. So that is the point. Now our intention is I should take this and take the second number, first and second number, and add it. Okay, and I know that first number is at 9050, second number is at 9051. So further writing a program, I will tell one concept about addition instruction, because that logic will help you to write a next line. So logic of add instruction is, it will be add accumulator comma some register, R0 to R7, any register we can use here, any register we can use. So generally this syntax is add, this is an instruction, then the source comma destination. Now here I am using accumulator as a source, destination is R1. Okay. Now what we can do is, means one data, these are the two data which need to be added. So according to this program, this logic, what I can say, this among these two, one data should be in accumulator, the other data should be in R1. So now what I will do, I have assigned 9050 to DPTR. So at DPTR what do you have? 8A. Let me take this into accumulator. So let me take this into accumulator, because I know that we should get an accumulator as a source. When we use an add instruction, here it should be A, accumulator. Here you can use R0 to R7, any register, right? So first I will take this 8A into accumulator. So how to do that? We have an instruction called move x A comma at DPTR. See what happening here is, at DPTR is 9050, at 9050 I have 8A, that will be taken to A, accumulator, and we are moving it from external memory, so it should be move x A comma at DPTR. So we got the first data into accumulator. So now what happened here, accumulator will be having 8A in it. Just for your understanding purpose I have written this. After semicolon whatever you write, that is a comment. Okay. So I got first data into A. Now what I need to do, I should go for the second data. So where is the second data? It is there at 9051. So 9051 means, now what you need to do is, you should remove this and you should enter 9051 into DPTR. So instead of that, what I can do, I can just increment the DPTR, because I know that it is 9050. If I increment, you will get the 9051. So we can write increment DPTR. So let me not write it like this, I will write it here. Increment DPTR. So now DPTR is going to be our address of 9051H. Okay. So 9051 is assigned for DPTR. Now this data has to be moved to register R1. Okay. I am taking R1. You can take R0 also. Right. Let me take R0. So I want this in R0, and then I can have an instruction called add A comma R0. Both will be added together. Now how to move this to R0? You may follow this. You may get this line. Move X R0 comma at DPTR. But this will be a wrong instruction, because we have a limitation that whenever you are fetching a data from external memory, whenever you are taking DPTR, okay, that can be communicated only through accumulator. Means I can use only accumulator here. I cannot use any other registers. So it means that I can't write this. Again, what happened here? I should write it like this. I cannot directly move this to R0. Register to register is not possible. I cannot move this to R0. Okay. So what I do? I will take it into A, and from A I will move it into R0. Okay. So that will be the concept. But before that, you should be careful that already we have something in A. In A, I have 8A. This data is already available. Right. So what we can do now? I will just move this into R0, because now this data I can't take this directly to R0. Okay. So what I do? I will take this into accumulator. So when I take this into accumulator, this will be overwritten. So take this into R0. First move this into R0 and take this into accumulator. So that's what I'm going to do now. Move R0 comma A. what happens now? R0 will have a number called 8A. Whatever the data you give here, that will be in R0. So instead of taking it into accumulator, what I have done now? First I have taken it into accumulator. From accumulator I will take it into R0. Okay. Then move this data into accumulator. Again that is in DPTR 9051H. So you should use move x a comma at DPTR. Here what happens? Accumulator will get C2 because DPTR is incremented as 9051 and at 9051 I have C2 and this is given to accumulator. Okay. So this is how the data has to be taken into accumulator and a 8-bit register. Because we have made this changes here because of the restriction that DPTR content can be taken only through accumulator, not with any other registers. Okay, I hope this is clear up to this. If these concepts are clear for you, just press the like button there. That will motivate us or motivate me to update new videos. Okay. Now let's see what next. We got up to this. We got these two information in the register and the accumulator. After this, just add it. Add A comma R0. So A comma R0. Now what happens? 8A plus C2. This is going to happen here. In accumulator we have C2. In R0 we have 8A. Both are going to get added. And the result already, as we have discussed, it will be 1, 4, C. That will be the result. So whenever we go for an add instruction, whenever you add or whenever you use the arithmetic instructions like add, subtraction, division, multiplication, the result will be stored in accumulator. Okay. Here the result is 14C. It is more than 8-bit. You can read it like this, 014C. It's a 16-bit data. But accumulator is 8-bit register. You can't store 014C in accumulator. Okay. So what happens when we execute this? Only this 4C, the lower byte, will be in accumulator. It will be stored in accumulator. But 01 will be stored in B register. We have two registers, A and B, special function registers. Lower 8-bit data will be stored in accumulator and the higher 8-bit data will be stored in B register. You should know about this. Okay. So now as we got this result, A will be having 4C and B register will have 01. But our intention is I need to get this answer at 9052 and 9053. Right. So I want 4C at 9052. Right now, where do we have that 4C? We have it at accumulator. So just move this to 9052. That's it. Okay. So let's see how to do that. Right. And one more thing you need to understand here. If there is a carry, now we got a carry, then this B is going to become 1. If there was no carry, if you add something like 01 plus 02, you get the answer as 03. So carry is 0. There is no carry. If there is no carry, the content of B will be 0. Right. So we need to check the carry flag also. So what I do here is I will check for a carry flag also. So let me erase these comments and tell you what to do next. Right. So now after adding, the 8-bit result is at A, lower 8-bit result is at A. First let me take this into 9052 and after that we need to check for a carry. So first let me check for that. Alright, gem if not carry. If there is no carry, what I need to do? I just need to push this into 9052 and at 9053 I should give 00 if there is no carry. Okay, so that is a concept. If there is no carry, let me write skip. I'll write the label and I'll write that skip portion here. Skip. Okay. So what you need to do? I got the answer in A, so let me move it into 9052. So 9052, where we have that address, we have it in DPTR. DPTR is just incremented once. So right now DPTR is pointing towards this address. But I want to put it in 9052. So what I do, after adding this, I'll check for a carry. If there is no carry, jump to skip. Jump if no carry. That is the concept. So you will come here and what we do here, first I will increment DPTR. So the DPTR will be pointing towards 9052 now. DPTR will be pointing towards 9052. And there I should put that 4C. where do we have 4C? That is at accumulator. So move it to dptr. So we can write move x at dptr comma a. So content of a is given to dptr. At dptr is important. So 4C will be given here. We get 4C here. So this is done. I got 4C at this location. Now at next location I should get a carry. So next location is at 9053. Okay. Next location is 9053. So what do we do now is increment dptr, because next location is just more, it has to be 9053. So it will be pointing towards this. Increment dptr. Okay. Increment dptr. And now see, after incrementing, you should put what we need to put here. If there is carry, I should put 1. If there is no carry, I should put 0. So now if there is no carry, what should I put here? I should move this content as 0. Okay. So I should move 0 means, how to get that 0? Let me tell you where. So to get that 0 and to get that 1, what we can do here is, first let me assign that 0 to any of the one register. Let me assign that to any of the register. So the register which is not used here, that is R0 is used. So let me take it as R1. Let me take it as R1. Okay. So let me do it like this. Where is the register? Sorry. Let me do it like this. So what we have, this is an 8-bit register. So I will assign one register to mention this carry. So what I do, I will write, I will somewhere here in this allocation here itself I will assign move R1 hash 00H. See, this is what, how the way how you write a program. If I write it clearly, that will not make you sense, because we should understand step by step. Now we came to know that okay, I want to assign a carry here. How to assign that carry? I cannot just move the data directly over there. So first I will take it into R1. So I will assign R1. I will tell you what is this. I will assign R1 as 00. So R1 is considered as a carry now. Okay. If there is no carry, it will be 00. If there is a carry, then what we need to do? We need to make this as 1. So if there is no carry, we skip here. If there is a carry, it will come next immediately after that. So what we should write here is move R1 hash 01H, or you can increment the R1. So if there is a carry, R1 will become 1, and this 1 has to be given to 9053. That is what the logic is. Okay. So now what I have? I don't have a carry. I don't have a, sorry, I have a carry. 01 is a carry. I have a carry. So what we have done? If there is no carry, you skip. You go for this. If you have a carry, what happens? It will come down. So according to this logic, according to this input, I'll tell you what happens. Jump if not carry, I will jump to this line if there is no carry. But I have carry now. So what happens? It will come immediately after that. So if there is a carry, R1 will become 1. Okay. And where should I put this one? I should put this one at 9053. I can't take directly from B. Okay. I'm just using R1 instead of B. I'm using R1. I hope it is clear now. So after this, what happens? You will come here, increment dptr, that has been done, and 4C is obtained here. Now increment dptr, it is pointing towards this. Now here, I should put the value of R1. But I can't put it like this. I can't put move x at dptr, comma R1. This is not possible. I can use only accumulator to communicate with the dptr. So to avoid this, what we do, what we need to do now, put this value of R1 into accumulator first. So I will take that content of R1 into accumulator. So how to do that? Move accumulator comma R1. So whatever the value we have, 01 is given to R1, that R1 will be given to A. So accumulator will have now 01. Now this has to be given here. So we can write move x at dptr comma A. So now we get this. Okay, I hope you got it. I can't write move x at dptr comma R1. That is the limitation we have. You can't use dptr and register together. You can use dptr and accumulator only. Right. So that's why what we have done. First I will take that R1 to accumulator, and from accumulator I will put it into dptr. So you got that one here. That is the end. So we got the answer 1, 4, C. Okay, so after that we can stop the program. So to stop the program, we generally use an instruction called SJMP. I can write STOP. Here itself you can put STOP, and this is the end of the program. Okay. So now I hope this is clear. Let me make you once again simple clarity I will give you. This R1 is just used to identify the carry. If there is no carry, only this one particular line will skip and it will jump to this. So I will not make that R1 as 1. For example, say if I take an input like this 1, 2, 3, 5. Now what happens? 7 and 4. You didn't got any carry, right? So if you didn't got any carry, then what happens? Here it should be 0, 0, right? So if there is no carry, it will not increment this R1. R1 is already assigned 0, 0. Okay. So what happens? R1 will be having 0 only. It will skip this and it will jump here. Increment DPTR. Okay, it will give the answer here. 47 will be here, and that will be here. Increment DPTR 9053. And now R1 is assigned to A. Now what is R1 here? We skipped it. Now R1 is already a 0, 0. So it will be 0, 0. 0, 0 will be in that. So if there is no carry, that is what's going to happen. Okay. So I hope this concept is clear. Now try the same concept for the some other examples. If this is clear, like the video and share it with among your friends. And also don't forget to subscribe to the channel. Thank you.